Picture this. You're hiking through the scorching outback of Queensland, Australia. The sun beats down mercilessly as you navigate the cracked, dusty terrain. Suddenly, you spot what looks like an unremarkable snake. No bright warning colors, no aggressive posturing, just a modest brown serpent with a dark head peeking out from a rocky crevice. You might think it's harmless, maybe even consider getting a closer look. But here's the terrifying truth. You're staring at a biological weapon so perfectly engineered that a single bite contains enough venom to eliminate 250,000 mice. One drop could end over 100 human lives. This is the inland taipan, and its venom represents evolution's most devastating masterpiece. Most people have never heard of this creature, and there's a mind-blowing reason why. Despite possessing the most toxic venom on Earth, not a single human has ever been recorded as losing their life to an inland taipan bite. Think about that for a moment. Nature's ultimate chemical assassin has a perfect record of 0 human casualties. The numbers behind this snake's lethality are absolutely staggering. While a king cobra needs to inject 420 milligrams of venom to be lethal, the inland taipan accomplishes the same devastation with just 44 milligrams. That's like comparing a sledgehammer to a surgical scalpel. Both deadly, but one infinitely more precise. In laboratory tests, the inland taipan's venom has proven to be 7 times more potent than the hook-nosed sea snake, 23 times stronger than the Indian cobra, and a shocking 72 times more lethal than the king cobra's venom. Yet this biological nightmare remains virtually unknown because it inhabits some of the most remote, inhospitable terrain on the planet. But this raises a fascinating question that scientists have been trying to answer for decades. How did evolution create such an impossibly lethal weapon? The story begins millions of years ago, when the world looked completely different from today. During the Jurassic period, Earth was dominated by dense forests and humid climates. Early snakes were perfectly adapted to this environment. They were constrictors, powerful ambush predators that relied on mechanical force rather than chemical warfare. These ancient serpents had robust spines and incredibly strong muscles that allowed them to wrap around their prey and squeeze until blood flow stopped. It was brutal but effective. The thick vegetation provided perfect cover for this hunting strategy. A snake could hide motionlessly for hours, strike with lightning speed, and trap its victim before it even knew what happened. For millions of years, this system worked flawlessly. Then everything changed. Around 23 million years ago, during the Miocene period, Earth's climate began shifting dramatically. Temperatures dropped, humidity decreased, and those lush forests started disappearing. What? In their place emerged vast, open savannas, grasslands, and arid regions. Suddenly, the constrictors found themselves in a world they weren't built for. You can't ambush prey effectively when there's nowhere to hide. The animals they hunted, small mammals and birds, could now see them coming from miles away and easily escape across open terrain. The snakes faced an evolutionary crisis: adapt or become extinct. This environmental pressure triggered one of nature's most remarkable innovations: venom. But here's where the story gets truly incredible. Evolution didn't just create venom once and spread it around. Different snake species independently developed their own unique chemical solutions to the same problem. Take the black mamba from Africa and the coastal taipan from Australia. These snakes are remarkably similar. They're roughly the same size, hunt the same type of prey, and their venom has nearly identical toxicity levels. Logic would suggest their venom should be chemically similar too, right? Wrong. The black mamba's venom is primarily composed of 3-finger alpha neurotoxins and Kunitz-type peptides, while the coastal taipan relies almost entirely on phospholipids and beta neurotoxins. It's like 2 engineers solving the same problem with completely different blueprints, yet achieving identical results. This is convergent evolution at its most stunning. The 3 Australian taipan species provide another mind-bending example of this phenomenon. The Central Ranges taipan uses almost pure alpha neurotoxins, similar to the black mamba. The coastal taipan sticks with its phospholipase-heavy formula. But the inland taipan, it went completely overboard and combined both approaches, creating a venom cocktail that's essentially biological overkill. Scientists still debate why the inland taipan evolved such extreme toxicity. Some theorize it's because prey is so scarce in the harsh outback that every hunt must be absolutely guaranteed to succeed. Others believe it might just be the result of random genetic mutations that happen to create something extraordinarily lethal. Whatever the reason, the result is a venom so complex and devastating that understanding how it works reads like a horror story written by a biochemist. When an inland taipan strikes, it doesn't just inject venom, it delivers a precisely orchestrated sequence of biological destruction. The snake typically bites multiple times, recoiling after each strike to allow the chemical cocktail to circulate through its victim's bloodstream. Within seconds, the first wave of toxins begins its assault. Hemotoxins immediately start attacking the blood itself, but in a way that seems almost contradictory. In small amounts, these proteins cause blood to clot rapidly, turning it into a jelly-like substance. But when they encounter the larger volumes of blood circulating through a living body, they trigger the opposite reaction. Thousands of microscopic clots form simultaneously throughout the circulatory system, consuming every available clotting factor. The result? The blood loses all ability to clot at the bite site, causing potentially fatal external bleeding. Simultaneously, other enzymes are weakening blood vessel walls and triggering massive inflammation throughout the body. But that's just the opening act. The venom also contains specialized accelerant compounds that speed up the absorption and distribution of all the other toxins, essentially turbocharging the entire deadly process. As this chemical chaos unfolds, my toxins begin targeting muscle fibers directly, causing them to break down and release their contents into the bloodstream. The kidneys, working desperately to filter out the damaged tissue, become overwhelmed and start to fail. The breakdown products are toxic to the kidneys themselves, creating a cascade of organ failure. But even if somehow an animal survived this first wave of destruction, the neurotoxins would ensure there's no escape. The inland taipan's venom contains two distinct types of neurotoxins, each with its own method of shutting down the nervous system. The alpha neurotoxins work fast, binding to acetylcholine receptors at the junctions between nerves and muscles. Acetylcholine is the chemical messenger that allows your brain to control your muscles, everything from conscious movements to the unconscious act of breathing. When alpha neurotoxins block these receptors, communication between the nervous system and muscles breaks down completely, leading to rapid paralysis. The terrifying thing is how quickly this happens. Within minutes, the victim loses control of their body entirely. Here's the one piece of potentially good news. This type of paralysis can be reversed. The binding isn't permanent, and if antivenom is administered within 30 minutes, the alpha neurotoxin effects can be counteracted. But there's a catch, and it's a big one. The inland taipan's venom also contains beta neurotoxins, specifically a compound called paradoxin, and these are an entirely different nightmare. Paradoxin operates on a much more sinister level. Instead of simply blocking communication, it systematically destroys the communication system itself. When paradoxin enters nerve cells, it begins breaking down phospholipids in the cell membranes. This releases arachidonic acid, which triggers a massive influx of calcium ions. In normal circumstances, cells carefully regulate their calcium levels, but paradoxin causes an uncontrolled flood. This calcium surge forces the nerve endings to dump every molecule of acetylcholine they contain in one catastrophic release. Now here's the truly diabolical part. Once all that acetylcholine is released, the cell can't make more. The arachidonic acid also blocks the reuptake of choline, the raw material needed to produce acetylcholine. It's like forcing someone to spend their entire life savings and then destroying their ability to earn more money. The communication system doesn't just fail, it becomes permanently bankrupt. But paradoxin isn't finished. If it reaches the receiving end of the nerve junction, it activates enzymes that completely shut down and remove the acetylcholine receptors from the cell surface. The result is irreversible. The brain loses all ability to communicate with the muscles, conscious or unconscious. The lungs can't inflate, the heart stops beating, and respiratory failure becomes inevitable. This is why paradoxin is considered one of the most potent naturally occurring toxins ever discovered. What makes this even more remarkable is the inland taipan's behavior during hunting. Despite wielding this biological weapon of mass destruction, the snake is incredibly methodical and almost conservative in its approach. It strikes quickly, then immediately retreats, allowing the venom to do its work. There's no prolonged struggle, no dramatic chase scene. The snake simply waits patiently while its prey succumbs to the inevitable. It's eerily efficient, like watching a master craftsman who knows their tools so well that every movement is deliberate and precise. Yet here's the ultimate irony of the inland taipan's existence. This creature, armed with the most lethal venom on Earth, is actually considered one of the most docile snakes in the world. Handlers who work with them in research facilities often describe them as surprisingly calm and reluctant to bite. The species earned the nickname fierce snake, but this refers to its venom's potency, not its temperament. In the wild, inland taipans are incredibly reclusive, spending most of their time in remote burrows and abandoned animal holes, far from human contact. They're masters of avoidance rather than aggression. This creates one of nature's most fascinating paradoxes. Evolution spent millions of years perfecting the ultimate biological weapon, crafting a venom so potent it could theoretically eliminate entire ecosystems. Yet this weapon resides in one of the planet's most peaceful creatures, living in some of the most isolated places on Earth. It's like discovering that the world's most advanced nuclear weapon is stored in a hermit's peaceful mountain cabin, never to be used except in the most extreme circumstances. The medical research community has become increasingly fascinated by compounds found in snake venoms, including those from the inland taipan. Scientists are discovering that these complex chemical cocktails, evolved over millions of years to cause harm, might actually hold keys to treating human diseases. The precise targeting mechanisms that make venom so deadly could potentially be redesigned to deliver medications directly to specific cells or organs. It's the ultimate example of nature's solutions, inspiring human innovation. But perhaps the most profound lesson from the inland taipan isn't about toxicity or evolution. It's about the assumptions we make. When most people think of dangerous animals, they picture aggressive predators with obvious warning signs, bright colors, intimidating displays, or fearsome reputations. Yet Earth's most venomous creature is a modest, retiring animal that most humans will never encounter. It's a reminder that nature's greatest achievements often come in unassuming packages, and the most powerful forces in our world might be hiding in the quiet corners we never think to explore. The inland taipan represents millions of years of evolutionary problem solving, compressed into a single, elegant biological system. Its venom is simultaneously a masterpiece of biochemical engineering and a sobering reminder of nature's capacity for creating perfect destruction. In a world where we often measure danger by noise and spectacle, the inland taipan teaches us that sometimes the most profound power comes wrapped in silence, waiting patiently in the shadows of the Australian outback, armed with enough chemical precision to humble our understanding of what it truly means to be deadly. That's a wrap on today's wild journey. But here at the Zoo-phoria show, we're just getting started exploring nature's most incredible stories. Subscribe if you want to keep discovering the shocking, hilarious, and downright unbelievable truths about the animals sharing our planet. Your next favorite animal fact is just one click away.